So today I wanted to, it was based on a customer support case where we helped, they were having issues with the toolpath collisions and just coming up with a way to resolve the tool axis, the 5-axis toolpath without collisions. So I came up with a couple different solutions and just kind of want to walk through what those look like. So here we have a mold, and it has some undercuts, some closed undercut faces here that makes it hard to access the walls. But on top of that, it's a tight area to machine. So something like a swarf tool axis, which is something that a lot of people would use for this, for a mold or for 5-axis, it's one way they would resolve the tool axis. So here I have a surface area toolpath, and it's using the actual surfaces of the part as the drive geometry. So you can see here it's these faces, and then we're doing a helical type toolpath to cut the part. So here's a preview of the toolpath, which the toolpath looks great. The issue is once you're down in the corners and coming into the corner, when the tool swings around, it ends up swinging into the wall. So here you can see we're having a collision, and so that's where we kind of had to start to look at other ways to resolve the tool axis. And from point, from line, there are other methods that would work, but you'd end up having a lot more swing than would be efficient on the machine. It would end up running a little slower because from line or from point would have tilt along sections where it wouldn't necessarily need tilt. And so anytime you have your rotaries or you're using your other kinematics, the more often you're using all 5 axes, the slower it's going to run, and the less smooth it's going to run. So the goal is to minimize the amount of tilt and swing that you have when machining. It's always ideal, if possible, to do more of a 3+2 machining where it's fixed axis. But that's not always a solution that will work, especially on geometries like this. So just minimizing the amount of tool axis change is ideal, and that's where the from point or from curve wouldn't be ideal here. So the other way to solve this would be interpolate. On the interpolate toolpath, you're basically here on the tool axis, you're going to define interpolate vector. You have a couple different options. You can do interpolate from drive or from part. Once you select the edit and you're inside of the control of the interpolation, you'll have this dialog here. Now new in 11, if you've used this before, the system points that would come up, depending on the surface you have, you might get, here we only got 2 system points, but there are times where you'll get many more, maybe 10. And in the past, in version 10, you weren't able to ignore these, and so you'd have to define them. And again, if you over define your tool axis, your tilt, you're going to get more swinging and more variance in your tool path, and your machine's going to have to synchronize the movements. And depending on the type of machine, that could really slow you down. So in 11, when you're using the system to define, you can select ignore point. In this case, it only came up with 2 of the system points, and I didn't need to ignore them. So it didn't have all of these defined, so what I did is I added points. I'll go ahead and copy this toolpath and show you the definition of that. and I'll go ahead and hit reset. And I won't redefine all of them, but just to kind of show where it starts. So here's what it came up with initially. So it had some of the corners, the vertexes in the corners or endpoints in the corners defined. But to control the swing, we need points at each corner and point of the corners at the top and bottom. So for the ones that exist, and the order of these doesn't matter, it's just that you have each section defined. So what I did to define these is I like to start with a Z normal to the floor and then start tilting from there. You can select the point in between the Z and X here and just type a value for tilt, and then you'll see it tilt away from the wall. So in this case I might want a little more. We'll go 15 degrees. And then so that it doesn't hit in the corner, I'm going to tilt it away from that wall a little bit. So I'll select between the Z and Y and maybe say 5. In this case, -5. And then to have a point also at this corner, I would just say add new set. Turn off the point on face and point on curve. Have it just to, actually all I need is the endpoint selection. So I'll say endpoint, and again just Z normal to floor, and then start tilting, maybe 8 degrees and 15, maybe 10 away. And then I'll just focus on this corner here to kind of show an example. So we don't have one up here at this endpoint, so I'll add another one. We'll add there, start with it normal to the floor, and then start to F3 will get rid of those dialogues, start to tilt it. So we'll say 8 degrees and 10 away from the wall. And then it's important, one more here. So this one I'm going to leave for a moment and jump down here. So then what I do so that we have a smooth transition from top to bottom is I'm going to look at what vector this currently is at so that I can match the one that's straight up from there along this edge. So I'm going to go into the specify vector dialog, and then to see what vector it's at, I like the spherical. I'm going to round out the values there so we get some normal tilt. So I'll do 16 and 17. And then I would select up here, go back into the vector dialog, select by coefficients, spherical, and I believe it was 16 and 17. And so now that'll be match so that it's basically it's going to average in between these points. If I had set this vertical or a different tilt, between the two it'll be half of the difference, and I don't want that. I want them to be the same. And so I did that for the other toolpath where I'll show you the end result. I did that going all the way around. So this takes quite a bit of time, and the reason for, again, is the reason for this webinar where I'll show the automatic tilt, where it's much faster and resolves a very smooth tool axis, and is basically automatic. So that's, I will show you how I got to that also. So this is one way that customers would resolve this issue where we're getting swing in the corner and having collisions. But setting this, I believe, took me maybe 10 minutes to set all the vectors, somewhere between 5 and 10 minutes. And then of course there's defining your toolpath, so that's separate. You'd have to make sure that you have the step down and everything's smooth. So I'm going to hit cancel on this, and we'll delete that example. So that is this toolpath here. So you can see the toolpath looks good. Again, going into the interpolate, you can see I have, and to look at it another way, you can see the IJK. So here's this point down at the bottom of this radius, and then the point at the top. They have the same IJK value or same tilt. So going all the way around, the points that are vertical from each other have the same values. What this looks like when you run the toolpath. Kind of swing it around here. And if I start, so it's very smooth. And if I go down a little deeper where we would have collision, so I'm in Toolpath Verify. In replay mode, you can click or select on the toolpath, and it will the tool will move to that point, and you can start from there. And then it's showing that we have a 5-axis toolpath up here. So I'll kind of slow it down, sorry. Stop. All right, so we'll focus on this corner here. So you can see it did resolve our collisions, and it's smooth. It gives you the right amount of control to be able to set this, but it takes some time. So that is the surface area with interpolate. And then we already went over the swarf. So these are all using surface area drive method, where you're picking a reference drive surface. It does not have to be the same surface as the part, but in this case that works well. So I didn't have to draw a reference surface, but you can draw a reference surface, and that gives you some control of the way that it projects the toolpath, and it can also give you control of the vector of the toolpath, which I've gone over in previous webinars. So drive method is surface area. For the last toolpath that we just looked at, it was interpolate vector for the tool axis. This one here is set to swarf drive. This is the first toolpath we looked at, where it coming around the corners, the holder collided with the part. So that's something that people would tend to use as a swarf drive. And then here, before doing the automatic tilt, this method is basically, it's a surface area drive toolpath. It's a variable contour set to surface area drive method. And what I'm doing here to prep for the automatic tilt is basically setting the tool axis relative to vector, and I set it normal to the floor, and so it basically turned it into a 3-axis toolpath. Now, I didn't have to use a variable to do this. I could have used the fixed toolpath. I'll show you where that's at. So under create operation and mill contour, you have your fixed contour toolpaths, and so you could use one of those, and that would you would also set the tool axis normal to the floor, and then you could use the surface area drive method. So surface area, I won't set that, and then you could set the tool axis normal to a vector. Again, it would be the floor in this case. And then you would do, from there, it would be the same as what I'm about to do with the variable. So you don't necessarily have to use a variable to use the automatic tilt tool axis, but in this case I did, just because I initially tried other settings, and so it was easier just to copy, paste, and change my tool axis type. So that's kind of using the NX copy and paste function, which I like, because you end up reusing your step down drive method, your speeds and feeds, non-cutting moves, the engage and retract. So it saves me a lot of time not having to set all of those, and then I can experiment with different ways of resolving the tool axis. So I did use the variable contour after copying, and then I set the tool axis to relative to vector to turn it into a 3-axis toolpath. I'm using, for the projection vector, the towards drive. I really like the towards drive and normal to drive projection vectors. Normal to drive would be for like the outside, core. Towards drive is optimized for cavities. And so I really rely on those two a lot. They work. And then the back for towards drive, you have control of your back off distance. That's basically how far it will project the toolpath from the tool. So that helps ensure that you're not going to project the toolpath onto this other surface if you have thin walls. Other than that, everything's set the same as when I was using Interpolate and Swarf. It's a helical toolpath, so it's a continuous helix down. And so that's what the other thing you'll do before the automatic tilt is turn off your collision checking. So under, let me back up one. So under cutting parameters and containment, I've turned the collision checking off for checking the tool above the ball because I want a tool path that has collisions, and then the automatic tilt is going to look at those collisions and tilt the tool path to avoid collisions. You don't have to turn off the non-cutting move collision. You can leave that on. Sometimes I do turn that off in addition to just to have faster processing time, and that is under non-cutting moves and more. And then there's this collision check here. So this is checking against non-cutting moves. So basically we have a toolpath that is 3-axis, and you can see here based on only one set of IJ and K that it's 3-axis. And if I was to play through this, maybe in the undercut area, you can see that it's definitely colliding, cutting right through that wall, and the machine operator would definitely not like that, and probably the customer would be mad too. Other than that, it's a good toolpath. The toolpath itself is smooth and also follows the contour of the part instead of doing air cuts across. All right, so then once you have your 3-axis toolpath with collisions, you can use a already tilted, so I could also have used this on the Swarf that had collisions only in the corners. What I like about using a vertical toolpath that's not already tilted, one of the things I like is it'll start at the top with a vertical toolpath. I'll show you that before we process it. So this is the this toolpath here has already been tilted, and I'll walk you through the steps of how to do that. But just to show quickly that at the top of the toolpath, if I look at this normal, it's vertical, and then as it gets into an area that would collide, so if I click down here further, it starts to tilt. So I like that. I like that it will cut portions that don't have collisions in just a normal 3-axis mode, which will usually cut faster, and why tilt if you don't have to? If you had done if you tilt the Swarf that already has tilt on the entire toolpath, you'll have that tilt from the top to the bottom, and then it will just adjust the tilt in the corner. All right, so here's our normal vertical toolpath that has collisions. And so we would right-click that and go to Toolpath, and then the Tilt Tool Axis. Now there are some bundles that don't have this this license. The advanced bundles include this, but it is also available as an add-on. So you have 3 different tabs here. You have the tilt or tilting, collision check avoidance, and then machine tool characteristics. I'm going to go ahead and keep original. There is a user-defined option that gives you some additional control to tilt from a point or a curve, but I find that most times the just original works best. Under the collision check avoidance tab, This shank of this tool is already relieved, so I'm not going to check against the shank or the neck. And I'm running a 30 thousandths tool holder collision or avoidance. So the clearance of the tool holder it's checking for is 30 thousandths. And that might be a little minimal. I tend to, I like to keep the machine operators on their toes. But you could, of course, increase that value. And then under the input section that I just expanded, you have how you want to control. So your avoidance direction, in this case, it's going to, I'm giving it the ability to use rotation or tilt as needed. Preference, I'm saying, is equal. The rotary axis will be from tilting. So it'll be rotating about normal to the floor. And then I'm giving it some values. And I just left these at the defaults. The areas I modified are the clearance, and then under machine tool characteristics, this max angle here was default to 90. I increased that to 130. Now that is controlling both the swing and the tilt, and that's the reason I went to 130. If they were separate, then I might give this different values. And then I increased the degrees allowed per step. For that, I would say, just test the results. There's no, formula for, set it exactly to a certain amount. But I kind of played around with the settings on this and didn't see any major changes. But if you have issues with too much tool axis change, then you could go into this area and minimize how much you're allowing it to change by. And then the main MCS axis, I normally set this to Y. It looks like I forgot to set it this time. I haven't found a big difference, at least in 11. But in this case, the Z is pointing here. So I would normally set that to the YM, but the results are fine, so I'll just leave that alone. So then we just say OK, and then it will process. And then I could actually, I was going to see, I think it goes fairly fast here. Yeah, it's about done. So we've used this on in our machine for different, especially molds like this. So now here's our toolpath that was 3-axis, and it has tilt. So we'll start at the beginning here. So you can see it's vertical. And then I believe on the second pass, it'll start, yeah, it started to tilt now. And that's due to that undercut there. So you can see looking down from the top, I'll slow it down a bit. So it looks like it, stop it there. Yeah, it looked like the tool was hitting, but it's just because I'm looking at it vertically. So it looks like the increase in the amount of swing I gave it, no, it looks good actually. I was seeing if there was a difference. We'll go down a little deeper. Go to the vertical. Yeah, this time I tried increasing the amount allowed per step, and I think I'm seeing a difference, but I'm still very impressed with the smoothness of the transition. And there we go. We got a collision-free toolpath just by a couple clicks and then letting it process. So much faster than the interpolate. I know we're wrapping up here, so I'll just I'll glance over this other part. You can use it. I didn't. I allowed some direct transitions here, but this is a roughing toolpath, so you can use it with cavity mill. You just have to make sure you're using a ball mill. And so I roughed the cavity out with a regular end mill and left collision checking on. So as the short end mill went down the tool path, it basically stepped in. I'll show you what that end mill looks like. So you can see it's short, and if you're down in the cavity, of course, it's going to hit the walls if it's roughing. Trying to get up, near the wall, it's going to collide. But I had it basically using the cutting parameters, containment, and then just setting the amount that I wanted it to clear. It filtered that tool path and then left the steps. So then I did a rest mill, semi-rough, regular 3-axis, and then did the tilt. And so now if we watch this tool path, it'll start at normal 3-axis toolpath at the top, and then once it gets down a little bit, I'll clean it up or slow it down. And so here it started to tilt, not on the rapid move, but all right. So slow it down, and you can see it's tilting away from the walls. So I've used that and on roughing toolpaths before. I would say it is much smoother in 11 than I've seen previously. The version that I used it on, it worked, but it was a little scary to watch at the machine. So that is the automatic tilt tool axis, and then a couple other ways, also the interpolate tool vector. So both of those work well when you have tight spaces where you're getting a collision tool path or too much tool axis change with the other options available. Let me see if I have any questions. All right, let's see. And yes, this webinar will be recorded. So you'll be able to see, let me expand this here, there we go. It's having a hard time seeing the questions. So we will upload this webinar and then also the file itself so that you can have access to it and look at it. Okay, so there's a question on inherited part in the IPW. So for it is underneath a workpiece that has both the part defined and the blank. In this case, so I didn't have to do rough it out first. I wanted to visually be able to show material removal. I basically set the blank to offset from part, so similar to a casting. And that allows me, without having roughing toolpaths, to show material removal without having the pocket full of material. Basically, it just, so here's 3D dynamic where it will show that material. So there's the 60 thousandths of material offset from part being removed. And of course, your step downs would be finer, but just for the sake of processing time, I have the step down pretty rough.